Here we have a triangle, and it says right triangle. Suppose the measure of angle B is 60 degrees, so I'm going to label that. And it also says that side B equal 10, so I'm going to label that as well. And I don't have what it asked for, but essentially we need to solve the triangle, which means find any missing angles and any missing sides. Well, the easiest thing to do is to find the measure of angle A, because all the three angles in the triangle have to add up to 180, and if it's a right triangle, 90 of that 180 is already used up, so we got 90 left. So the two acute angles in the triangle are complementary, or they have to add up to 90. So this one must be 30, because 90 minus 60 leaves us 30 for that angle. So the measure of angle A is 30 degrees. Now, I can find sides A and C because it's a right triangle, and I can connect them with trig functions. So first of all, the side I know is 10, that's opposite. And let's go ahead and find A, that's adjacent. So we know that tangent, so I can write tangent of the angle, which is 60, is going to be opposite, which is 10, over adjacent, which is A. So now I'm going to solve this for A. So I'm going to multiply both sides by A, and I'm going to divide both sides by tangent of 60 degrees. So I've got A by itself. And so A equals 10 tangent of 60 degrees. So let's figure out what that is. 10 over, okay, I'm going to go over here to the left and figure out the tangent of 60 degrees. So tangent of 60 degrees, I know the quotient identity for tangent. Tangent of 60 is sine of 60 degrees over cosine of 60 degrees. And those are unit circle values, I know. They're going to be here in quadrant 1, smaller x, bigger y, so I know that's going to be 1/2 and square root 3 over 2 for my values there. So to figure out the tangent of 60, I'm going to take the square root of 3 over 2, which is the sine of 60, and divide that by 1/2, which is the cosine of 60. Now I can take this and flip it over, so I'm going to have 2 over 1 like that, and the 2's will cancel. So A is going to equal 10 over square root of 3, and there's no need to rationalize in trig. It's not wrong if you do, but you don't need to. All right, let's go ahead and figure out C then. Now we have a couple of options for C. If I know both legs, I can do a Pythagorean theorem and find C, or I can use a trig function and find C. I'm going to use the trig function just because we're practicing trig functions. So the side I know is opposite. The side I want to find is the hypotenuse. Well, sine of an angle is opposite over hypotenuse. So sine of 60 degrees is going to be opposite, which is 10, over hypotenuse, which is C. Then I would do those same steps of I need to solve that for C. So I'd multiply both sides by C and divide both sides by sine of 60. And then C equal 10 over the sine of 60. Well, the sine, I've already got this drawn over here, of 60 is square root 3 over 2. So this is going to be 10 divided by square root 3 over 2. Not necessary to rationalize, but you should always simplify. And I have a complex fraction, so I'm going to flip that over. 2 over square root 3. This could be like over a 1. So it looks like my final answer is going to be 20 over square root 3 for the length of side C. Let's just run a little Pythagorean theorem to check that. So side A, which was 10 over square root of 3 squared, plus side B, which is 10 squared. Let's see what that equals. So if I square that, that's going to be 100 over 3 plus 100. And kind of squishing things in here. So if I get a common denominator, that will leave me 400 over 3. So what I did there is I put this over 3, multiplied top and bottom by 3. 300 plus 100 is 400 over the common denominator of 3. That is C squared. So if I square root that, square root of 400, let's square root 4 is 2 and square root of 100 is 10. So that's going to be 2 times 10 or 20 over square root the bottom, square root of 3. So indeed, it checks.